Welcome to Easy Math TV. This video is going to solve a problem where we're going to do a hypothesis test on a proportion, on a population proportion. So we're going to actually solve a real world type problem, and we're going to use Excel as a template so that we can use it for any hypothesis test of a proportion. This is going to close out our playlist on inferential statistics on a single random variable. And basically, this playlist focused entirely on population means and population proportions. If we do more inferential statistics videos, they'll be on other topics, so I'll create a new playlist for those. But for now, this is going to close out our series on inferential statistics on a single population mean or population proportion. So the problem is stated as such. The percent of adults living in the United States that favor current U.S. policy toward Israel is reportedly around 60%. A survey of 982 adults was conducted, and 548 said that they favor current policy. Use the results of the survey to test the claim at 95% confidence that the actual percentage is lower than 60%. So the first thing to do is to write your null hypothesis and your alternate hypothesis, and also to consider like what it is that we're going to need to solve this problem. And the very first sentence actually gives us a clue as to what the hypothesized proportion is, because it just tells us what the status quo is. The status quo is that basically 60% of adults living in the United States favor U.S. policy toward Israel. That's what is reported, okay? But even a stronger clue is given in the last sentence, where it says, use the results of the survey to test the claim that the percentage is lower than 60%. So the claim here is actually going to be our alternate hypothesis, since it's not a statement of equality, it's a statement of inequality, and that the percentage is lower than 60%. So our alternate hypothesis is written down below here. You see that HA is going to be that the true proportion phi is less than 0.60. But your null hypothesis is always going to be the statement of equals. So that's phi equals 0.60. That's always going to be the null hypothesis, or the status quo. Okay, so there's your null and alternate hypotheses. And now we're going to use the spreadsheet to help us to make a decision about that. So under columns B and C, these are our calculations that we're going to need. And then columns E, F, and G, we ended up not needing column H. Just columns E, F, and G are going to give us the information that we need to make the decision. So this is going to help us with the decision, okay? All right, so let's look at each of these numbers. In C4, because we were given the number of adults that reportedly said yes, that is our X. That the 548 is our X. That's the number of responses that were in support of what it is we're studying here. What it is, like what is considered to be a favorable response. So how many favorable responses did we get? 548. That's your X, okay? Go down to row 5, and that's our hypothesized proportion. So in cell C5, that's our 60%. In cell C6, that is our sample size N, which is the number of people that were surveyed. So that I just typed that number in. These are not formulas, these are just numbers we typed in. And the sample size N is 982. The sample proportion p hat, we can actually calculate that in this problem. In some problems, you're just given the value of p hat and you can just type it in. So let's just calculate that here. That's equals C4 divided by C6. So that's equals X divided by N. To get your test thresholds, you use your hypothesized proportion for that. So the first thing is to multiply the hypothesized proportion times the sample size. That's equals C5 times C6, and that's going into cell C8. And then the second threshold is equals parenthesis 1 minus C5, close parenthesis, times C6, and that's going to give us our other number. Those threshold numbers both have to be larger than 5. If they are not larger than 5, we cannot proceed. But since they are both way larger than 5, we are totally fine to proceed. In cell C10, I'm typing my standard error of proportion, or I'm calculating it. That's equals SQRT parenthesis C5 times parenthesis 1 minus C5, close parenthesis, slash C6, and another close parenthesis. So again, that's equals SQRT parenthesis C5 times another parenthesis minus 1 minus C5, close parenthesis, slash C6, close parenthesis. Again, like you can pause this video at any point along this way and put the window to the side with your Excel spreadsheet open in another window and just, compare and just make sure that you're typing in exactly what you see here. So if you pause the video and keep it open in one window and you have your spreadsheet in another window and just type as you go, you can make sure that yours looks exactly like this. Our confidence level is typed into cell C11, and that's just 95%. Our significance level then is equals 1 minus C11, equals 1 minus C11. So those two percentages should add up to 100%. The last calculation then we need to make here is our actual z-value. And the z-value is just equals parenthesis C7 minus C5. So it has to be the p hat minus the hypothesized proportion, close parenthesis, slash C10. So divide by the standard error of the proportion. And you'll notice our z-value is a negative number. So z-values can be positive and negative, and it's really important, it's critical that you subtract in the correct order, that it's your p hat minus the hypothesized mean, and not in the other order, okay? So that's our z statistic. So over here on the right in columns E, F, and G, we have our p-value calculations, and then our significance levels are copied over. So let's start with column G because that's the simplest. Just type equals C12 into all of those rows, all three rows. So depending on what our alternate hypothesis is, we're either going to want to look at row 5, row 9, or row 13. So each one of these in column G is just going to be equals C12. You can see that I just did that individually, equals C12. But I also formatted it as a percent so that we would actually see the number as a percentage. Okay, and you can expand the number of decimal places or reduce the number of decimal places using this menu above at the top. Okay, so these p-value calculations are a bit complicated, so pay close attention to them. And the reason they're complicated is that Excel, in basic Excel, unless you get some extra packages, add-ons, um, the basic formulas are kind of complicated. It doesn't just do a hypothesis test, unfortunately. So in cell F5, I want you to type equals 1 minus norm.s.dist, parenthesis, C13, comma, true, close parenthesis, and then hit enter. So that's not so bad. But the thing you can't forget to do is the equals 1 minus norm.s.dist, parenthesis, C13, comma, true. Okay, you can't forget to do that. The next p-value, this is associated with, notice the alternate hypothesis is really important. It's important that you put the correct p-value with the correct alternate hypothesis, because the one that we did in row 5 is associated with phi is greater than some number, and the one that we're about to do in row 9 is associated with the alternate hypothesis phi is less than some number. So that is very important that we have our less thans and greater thans straightened out here. So for phi less than some number, into cell F9, you're going to type equals norm.s.dist, parenthesis, C13, comma, true, close parenthesis. Again, that's equals norm.s.dist, parenthesis, C13, comma, true, close parenthesis. And again, that's the p-value for the alternate hypothesis that we're interested in, actually. Phi is less than 0.6, right? So we're going to be looking at that in a moment. But just for the sake of seeing what the formula is for, in case the alternate hypothesis was phi is not equal to C5, or phi is not equal to a number, let's look at what that formula looks like. And this is pretty complicated, so so you may want to pause the video and write this down, exactly what you see here. So F13 is you're going to type equals, and it's 2 times, left parenthesis, 1 minus norm.s.dist, left parenthesis, ABS, which is absolute value, another left parenthesis, C13, right parenthesis, comma, true, and then 2 right parentheses. So there are 3 pairs of parentheses here. There's a pair of parentheses out around the entire thing that's getting multiplied by 2. There's a parenthesis that has to do with the norm.s.dist function, and then there's a pair of parentheses for the absolute value, because we have to take the absolute value of our z statistic. Okay, I'm just going to say that whole thing one more time. In cell F13, you type equals 2 times, parenthesis, 1 minus norm.s.dist, another parenthesis, ABS, another parenthesis, C13, and now close the parenthesis, comma, true, close parenthesis, close parenthesis. Hit enter. Okay, and with our data that we typed in, that should be 0.73%. All right. So if we look at our problem that we're solving, our problem involves an alternate hypothesis that says phi is less than 0.60. So take a look at our p-value. Our p-value is 0.36%. And we are comparing that with our alpha, which is 5%. So when we look at our decision, Our decision is one of two things. We are either going to reject the null hypothesis or we fail to reject the null hypothesis. And we've stated this before. If the p-value is less than the significance level, and that is true in this case, because the p-value is 0.36% and the significance level is 5%, then we must reject the null hypothesis in favor of the alternate hypothesis. So the decision is always stated in terms of the null hypothesis. Do we reject the null hypothesis or do we fail to reject the null hypothesis? Then when you make your conclusion, when you write your conclusion, always state that in terms of the claim. So in this case, there is sufficient evidence. And when we say sufficient evidence, we're talking about the fact that we are rejecting the null hypothesis. There is sufficient evidence to support the claim that the true proportion is in fact less than 60% of the adult population. So always state your conclusion in terms of whatever the claim was that was being made. Do we support the claim or do we not support the claim? Is there sufficient evidence? Is there not sufficient evidence? So when you're rejecting the null hypothesis, there's always sufficient evidence. When you fail to reject the null hypothesis, there's always insufficient evidence. In other words, more work would need to be done. So that is your answer to this particular problem, and that concludes our series on hypothesis testing of a one sample mean or a one sample proportion. I wish you would like, subscribe, comment down below if you feel that maybe future videos that I might post on statistics. There's a lot more topics. There will be a lot more videos. And subscribe if you want to get updates on new content that gets posted in the future weeks. So good luck.